Hello everyone, welcome back to this channel. So in the previous video, I have discussed how many types of conditional statements we have, what is switch case, and how many types of loops we have, how we use that loops. We did a practical session. So now in this video, let's see encapsulation and what is object, what is class, what is stack memory, what is heap memory, what is boxing, what is unboxing. Let's see one by one. Encapsulation is nothing but hiding the appropriate data and showing only essential information. Hiding the data, so whichever the data required to show to other classes, we will only show that members and methods. We are going to restrict access to other methods using access modifiers. We have already discussed access modifiers in the previous sections. So here let's just simply let's see one or two examples how we restrict this encapsulation. So we are not going to show essential information, hiding essential info and showing only important info, necessary info. This is what encapsulation is. Object is a collection of data and methods, so it is a instance of a class. Instance of a class. Class is a blueprint. Class is a blueprint of objects. So it can contain members, functions, and any other information. Stack is a memory type, so it is LIFO memory management, so it will manage last in first out. Heap means it is a generic memory, so it is like a board. In board we will write anywhere, so like that heap memory will store anywhere. Boxing means converting value type to reference type. It means converting integer. Suppose we have int value which we are converting to object, then it is called as converting value type to reference type. Unboxing means converting reference type to value type. It means object to int. We are converting integer to object. Here we are converting back to integer, object to integer. So let's practically discuss all of these things. Okay, now let's see one or two examples for encapsulation, as we already covered access modifiers, all of access modifiers. Let's see here. So here, if I create public member, let's create a public member here. Public int I equals to 10. So this can be accessed in other classes when we create a private member. J equals to 20. So here when I create one method, for example I want to create one method, so here I would like to do I plus j, int result equals to I plus j. So here I want to calculate with any kind of logic we want to do only internal, which should not expose to other classes. We're going to use private. So here we are encapsulating it, so this is called encapsulation. So we are hiding essential information from other classes. So we are showing to other classes. So this is the way we use encapsulation to bind the data. So next, let's see the object. So object, as I said, it is an instance of class. So for example, if I want to create an instance of a class, check internal class new check internal. So this is how we create an instance, as we already checked this. Now if I want to access any method from this check internal class, so we have to parse this and use from this class. Why? Because we are converting this to object, and we are created an instance. To use this, we have to use like this. So if I directly create check internal c equals to new check internal class, if I create instance like this, we can directly use c dot check. Like this we can use. So this is now we are converting to reference type, and we are extracting the method. Let's see another scenario. So if I have a integer I equals to 10, so this is a object is a reference type, this is a value type, integer is a value type. So we are converting value type to reference type, and here it is converting back to value type from reference type. So this is the way how we box and unbox. So this is called boxing, and this is unboxing. Okay, now let's see this result for I and j. Console dot write line I and j, and you can see the type of it. Console dot write line, both are integer types. Write line j dot get type. Now let's run and see. So you can see it is printing the values, and both are integer types. Even we are assigning to the object, it is an integer type. So we can also assign a string type. For example, yes, hello. Let's see this output is dot get type. Yeah, now you can see it is string type. Even if we convert this to actual value type, it will be same result. So we are explicitly converting it s2 and s2 here. You can see that same result is came. Similarly, we can do for any other data types. So now let's see what is stack memory and what is heap memory. We have other memory managements like garbage collection and unmanaged memory also. But as of now, let's see what is stack and what is heap. So as I said, it is a LIFO, last in first out. It will erase the memory when it is out of scope. Let's see one example. So here I'll just create one more method, public static void method test method. So now let me create one integer I equals to 10. So it is now it is allocated as allocated in stock memory. Now it will get freed when the scope of this method is completed. So this is called as stack memory. So this will be freed when the scope of method is completed. Now let's understand what is heap memory. Heap memory also similar. Public static test heap method. Similar to this, let me create a class check internal new check internal. So this is a reference type. When it is a reference type, it will allocate in heap memory. So it will also get freed deallocated when the scope is completed. But the problem here is when we create a reference type, it is small memory. Reference types are always small memories. And heap memory is large memory and random allocation in the memory. So it will take more memory and allocation also random, but it is a small memory. Allocation is last in first out. So we have to manage the memory when we use these variables. For example, we have created a class instance over here, so it will be accessible throughout this class. So it is a major problem. So it means we are creating huge memory over here. So by default, if we create a member without any access modifier in C#, it is private. Actually, let me specify private also. So here this is accessible throughout this class only, and whenever this class is getting freed, then only this heap instance memory will get freed. So we have to carefully manage the memory while we are doing coding. So we can understand deeply how this memory management works and how we free them. So let's see one of the example here. For example, if I want to free this memory, we can assign it to null. So this will handle, this will deallocates. So now it will deallocates by garbage collection. So we can have multiple mechanisms like dependency injection and a few other architectural mechanisms to handle the memory management perfectly. It is most important to handle the memory management while we are developing any application. So let's deeply we can discuss in further videos about memory management and dependency injections in the future videos.